Now explain this problem. The problem is sum of beauty of all substrings. So basically they have defined something called beauty here, which is the difference between the frequencies of the most frequent and the least frequent characters. Okay, so we basically uh, so for any substring or any string, if the difference between the largest frequency of character and the lowest frequency character is basically defined as beauty here. And what the program wants us to return is given a string, we have to return the beauty of all the substrings, right? So there are some examples which clearly define uh, I mean, which help us understand what it particular what it means, what beauty means, right? So what will be our approach of solving this problem? But so I think the approach that we are going to use to solve this problem is basically a simple prefix sum approach. So for example, basically what we want to know is the frequencies for every substring, right? For every substring, what should be the frequency of all characters? If we know for every substring what is the frequency of all characters, then obviously we can go through that frequency vector for every substring and figure out what is the maximum minimum frequency, and then subtract the minimum frequency from the maximum frequency. So that's the core logic of the problem. Let me explain what I'm going to do. Suppose I have, let me take the example case only. A B C B. Okay. A B C B, right? So what we can do is that we can construct a vector of frequency. What I mean to say is, suppose for every index of the string, we'll construct a vector, right? The prefix vector. What I mean is, at this I equal to 0, what will be the prefix vector? Basically, corresponding to 0, which is basically corresponds to a, it will store 1, and everything else will be 0. There is nothing, right? If you look at this, then the prefix vector for I equal to 1 will be 2 here, because from starting from 0 till this particular index, we have found 2's, and we don't have any other letters, so we'll keep everything as 0, right? And similarly, we just go on. I'll just explain you what will be here. So for the prefix vector for at I equal to, this is what, 2 3 and 4. At I equal to 4, the prefix vector would seem something like this. You will have 2 here, and then 2 for B, because B happens here and here, and then 1 C, and then everything else would be 0. So that's the prefix vector. Now suppose we take this substring, right? So the substring is starting from I and ending at J. So here J is 4 and I will be 1, right? So starting from I equal to 1, J equal to 4, the substring that we have is BCB. Now how do we calculate a frequency vector for this BCB? We basically subtract the uh, sorry, pardon me, from I equal to 2, I mean from I equal to 2 to J equal to 4, we want to find the frequency vector, right? So how do we do is, we have this prefix vector at I equal to 1, right? And then we have this prefix vector at I equal to 4, right? So basically we subtract all the individual frequencies, okay, which makes sense. So now we subtract all the individual, is basically a kind of a 1D matrix subtraction, right? Simple, or 1D vector subtraction. We subtract everything, right? So we'll subtract this from this. So the what will we get? We'll get 0 here, 2 here, 1 here, and then 0, right? Which is what we have, right? Which indicates that we have 2 B's, 1 C, and nothing else, no other characters, which is what we have. So using this prefix array for every substring, we can basically figure out the kind of or frequencies of all the letters which are happening in that substring. And then once we have all the frequencies, then basically we iterate through the entire vector to figure out the maximum frequency, which is 2 here, and then iterate through the entire vector to figure out the maximum non-zero frequency, which is 1 here. 0 is not included because 0 means that the character is not even present. So that is not filled. So the maximum non-zero frequency is 1. And then if you talk about what will be the beauty of this substring, it will be 2 minus 1, that is equal to 1, right? So that's the basic logic which I'll use to solve this problem. Now let us dive into the code and see that how this is being implemented. So this is a simple utility function called find max value. Given a particular frequency vector, it will basically figure out the maximum value. It's a very easy code. You initialize the max value and then go through everything. Obviously, when num equal to 0, this doesn't hasn't any significance because basically the character is not present in the particular vector. So I mean zero indicates that there is no character. So its frequency is 0. That means there is no character. So it is of no significance. So basically then, and then if it is not 0, then basically we update the max value if it is required, and then finally we return the max value. The same thing we do in the minimal case. For the minimum value, we'll take a large value because that's what we do when we take minimum. We try to compute a minimum across an array, and then obviously when the character is non-existent, then we ignore this because we're only looking for non-zero minimum frequencies, and then obviously we try to update the minimum value if it is required, and then return that minimum value. So these are now I explained you to both the utility functions, which are very simple. And now what is happening in the main code? We define this frequency vector, right? The vector of vectors. So if I go back to the screen, so you can see all these vectors are there. So the length will be basically the string length. It will be s dot length elements, right? Starting from 0 to s dot length minus 1, right? Obviously. And then for every vector will be of 26 size, representing the 26 letters that are there from 0 to 25. So that is why I have defined it here and initialized all the frequencies to 0 for every index of the length, right? And then when we are then what we do, we have to populate this frequency. So this is just population of the kind of the frequency vector, right? Or it's a you can say that it's a two-dimensional frequency vector population here that is happening here. So we basically for every index, if just give me a moment. Put in my charge. Okay, I'll be fine. Sorry for the delay. So basically, what we are doing here is, so if I is equal to 0, then obviously we just increment the frequency array, right? Because here like we don't have to inherit any value, right? Because for this frequency vector, we have to inherit the so we have to inherit the values which are there in the previous frequency vector, and then add this particular character's frequency, or increase this particular character's frequency by 1. So this 1 becomes 2. Basically copy the entire vector, and then this 1 becomes 2 because at this index the character is a. So that is what is happening here. Obviously for I equal to 0, there is nothing to copy, so we are just increasing the frequency corresponding to the letter that is present at that index. In this case I equal to 0, and then if no, we just copy the previous vector and then increase the index, right? And here what we are doing is that basically, so this is just going through all the substrings, right? I equal to 0 to s dot n minus 1 and j equal to 0 to I. So going through all the substrings, and then for every substring we are trying to calculate the frequency substring vector, which I showed you here, right? For this BCB, this frequency vector would be this. That is exactly what we're trying to calculate here. For every substring, we'll basically, if j equal to 0, then obviously we need to take I equal to x, because what we're trying to do is, suppose you remember, right, when we're trying to find the frequency vector between I equal to 0 and 4, we basically subtract the frequency vector of I equal to 4 and and then this index, which is the index 1 lesser than j here, right? In this case it was for BCB it was index 1. So we subtract 1 less than j, For j equal to 0, there is no 1 less than j, because j equals 0 is the left limiting point. And then for that case in which so this is like for j equal to 0 means all the substrings which are starting from the start of the string itself, j is here, so there is nothing on this side, right? And then for that case, if you want to calculate the frequency vector of this substring, it will just be this prefix vector, for obvious reasons. Okay, so that is what is happening here. We are going through all the characters and then populating this frequency vector. And then if j is not 0, then obviously j minus 1 is valid, and then we do that this subtraction, basically a vector subtraction to corresponding to every character to calculate the frequency vector for that particular substring. And then once we have the frequency vector for the substring, we basically calculate the mean value and then max value using our utility functions, and then subtract them to find the find the beauty value for that particular substring. And then since we have to find the sum of all beauties, we add this to the accumulator, which is the result here. And then finally we'll return the value of accumulated beauties of all the substrings which are present in the a string, right? So I think I have explained it very well. Hope you understood this problem. This is pretty easy problem, it's not that difficult. Once you have the idea that this has to be solved using the prefix array concept, here it is prefix frequencies, a prefix 2D vector frequencies in this case, but the basic concept is the prefix array concept. And then once you have that concept, then it should be easy enough to solve this problem. Thank you. I'll see you in the next video. Bye.